Hello students, I hope you are studying for your exams. So let us discuss the dynamic programming second problem type, longest common subsequence. I know you are working hard for your exams, so am I for preparing the notes and recording the video. So this is the problem that we are going to discuss today. In the longest common subsequence, using the dynamic programming, and this is the question as projected on the screen. So you need to find the longest common sequence between two string. X is given as ACCGGTCGAGT and Y is given as GTCGTTCGG. So this is Y and this is X. You need to find the longest common subsequence. Find the length of longest common subsequence using dynamic programming approach with the pseudocode for the same. So let us see. So we'll see the complete step-by-step solution, what the evaluator expect, how to approach this question in the minimal time, what variation the question paper setter can ask. So this is the questions given the two string of the length m and n. You need to find the longest common subsequence for that. Okay. So first step in the dynamic programming is to draw the table. Okay, so the table will look like this. So note that the one common mistake the student do that they start from the index 1 in both x and y or one of them. Here you have to start both with the index 0 and the index 0 there would be null string. No string will be there. So if you draw the structure of the table properly, then rest is much easier. So you have to start from the index 0 up to the 9. So this on the column side, I have kept the y string GTCGTTCGG of the length 9. On the row side, I have put the x string I ranging from 0 to 11 ACCGGTCGAGT. Now we'll fill up this table one by one. So how do we fill up the table? Again, same as the LCS, we'll fill up in the column order from top to bottom like this. So we'll fill up first for the column value 1 from the top to bottom. Okay, like this. At any time, suppose you are filling this, so it will require only 3 value. It will utilize either this or this diagonal entry or this. So this 3 entry will be required to fill up any value. So similarly, we'll fill up this second last column, okay, followed by the last column. What does this, what is the meaning of this entry in the table? What is the DP state here? Okay, so let this table name as Cij. So the DP state Cij represent if you are taking the first I character in the X side and first J character in the Y side, what will be the longest common subsequence that it will be given by Cij. So Cij is nothing but LCS X 1 to I. You have taken the substring 1 to I in the X side, and in the Y side you have taken the substring from 1 to J. So this value is given by Cij. So you have taken a substring X from 1 to I and another substring Y 1 to J. This is given by Cij. So this will be 0 for the initialization. If I equal to 0, if either of the string is null, then this initialization will be 0. Okay. Otherwise, we'll first look if xi is equal to yj. If so, and ij greater than 0, we'll look in the diagonal entry ci minus 1, j minus 1, and we will do plus 1. Why? Because this we have already found the one common bit xy equal to yj. So length of the common string will be 1 plus and the sub problem ci minus 1 j minus 1. Otherwise, if they are not equal, we have to consider the two possible sub problem, either decrease 1 from the j, 1 from the y, keeping the x same, or decrease 1 from the x, keeping the y same. Whichever is giving the maximum, that will be the value. So this formula we are going to use to fill up the table. So let's see how to fill up the table. So for j equal to 1, we'll copy this, the 0 here, we'll see whether this G is equal to A or not. It is not equal, so the maximum of these two values, the up value or the left side, will be put here. So the both are equal, so 0 is combined. Again, the G is not equal to C, so the value will be this, the current value. This current value will depend upon either the up value or the left value, the max of these two. So max of these two is again 0. In the similar way, we'll proceed to the next value. So next value, we are looking for this. So this entry will be contributed by G is equal to G. So this Xi equal to Yj. So this will be contributed by the diagonal entry. So diagonal entry is 0 plus 1. So hence it becomes 1. Moving to the next entry. This entry, the row 5, the G is equal to G. So we'll look for the diagonal entry Xi minus 1, J minus 1, and we will do plus 1. This moving to the row 6, we see that here X side we have T, Y side we have G. This is not equal. So it will be the maximum of either the up or the left. So the maximum of 0 and 1, that is 1, it is coming from the up. So this is filled as 1. Similarly, we'll pull up the G is equal to, G is not equal to C here. So this will be the either maximum of 1, this upside, or the left side 1. So this is 1. This G is equal to G in this entry in the row number 8. So in the row number 8, we will refer the diagonal entry. The diagonal entry is 0, and we will add one value. So this become 1. In the row number 9, we have the A on the X side and G on the Y side. A is not equal to G. So we'll either take maximum of the up, that is 1, or the left side 0. So that is we are taking in the row 9 as 1. Similarly, in the row 10, G is equal to G. So we'll look in the diagonal entry. Diagonal entry, we have the 0. We'll add the 1 and we'll update the value in the row 10 as 1. In the row 11, we'll see that Xi is not equal to Yj. So G is not equal to T. So we'll look either the maximum of the up and the left. So in this way, we have filled up the column 1. Similarly, we'll fill up the column 2. Let me fill up for you. If you have understood, try to fill up it on your own and then match this. So for column 2, we'll copy. So we'll see whether this T is equal to A or not. This T is not equal to A. So this will be either the maximum of the up or the left. Both are equal. So we'll fill up 0 here. Next, this C is not equal to T. Again, the maximum of left and the maximum of the left and the up. So both are 0. So we'll fill up 0 here. Row number 3, C is not equal to T. So we'll again see the maximum of left and the maximum of the left. So left is 0 and up is also 0. So both are 0. So we'll fill up 0 here. In the row number 4, G is not equal to T. Again, we have to see the up and the left. Whatever is the maximum, left is maximum. So we'll put up the 1 here. Now again, T is not equal to G. So we have to look the maximum of up and the left, both are equal. So and equal to 1. So we'll put up 1 here. Now this entry, look for this entry. This T is equal to T. What we do when Xi equal to Yj, we go to the diagonal entry. What is the diagonal entry here? The Xi minus 1, Yj minus 1, that is 1. You add plus 1 to this value and your resultant value becomes 1 plus 1, that is 2. So you fill up the 2 here. I hope this entry is clear. Now again, T is not equal to C. So you check the up value, you check the left value, whatever is the maximum. Maximum is 2. So you put the 2 value here. Then again for the row number 8, you check the up value and you check the left value. So up value is more, that is 2. So you put the 2 here. For the row number 9, A is not equal to T. So you check the up value and the left value. The maximum is 2 from the up. So you copy the 2 here. For the row number 10, G is not equal to T. So you check the up value, that is 2, and the left value, that is 1. Maximum of these two is 2. So you put 2 here. For the row number 11, you check the up value, that is 2, because this T and T is equal. So you don't check the up value. So this T and this T is equal. So you check the diagonal value, that is 1, and you add plus 1. So as a result, you get 2. So the red color means the diagonal entry we are updating from the diagonal entry. So I hope the row 2, column 2 is clear to you. If column 2 is clear to you, can you please fill up the column 3 and the match, so that you will understand in detail how to fill up the column 3. So this is the result of the column 3. So you can match your value. Okay. So let us quickly go through the column 3 here. Okay. So this you are seeing that C here. So C does not match with A. So it will be the maximum of up or the left. So both are 0. So you get a 0 here. Then this C is equal to C. So it will come from the diagonal entry, that is 0 and plus 1. So you get a 1 here. So this is the update. So let us highlight in the red color. Update, this is equal xi equal to yj. So it is coming from the diagonal entry. Then again C is equal to C. So you go to the diagonal entry, add plus 1. So this is also 1. This G is not equal to C. So it will be the maximum of this 1, that is on the left up, and on the left both are 1. So you update here with the 1 in the row 4. For row 5, xi is equal to G, y j equal to C, not equal. So you again check the up is 1. You check the left, it is also 1. So you update the value here 1. Moving to the row 6, you have the T here. You have the T. This T is not equal to C. So you check the up, you check the left. Maximum is 2. So you update the 2 here from the left. For the row 7, this C is equal to C. So this is the case here. C is equal to C. So what to do if the xi equal to yj? You look for the diagonal entry. Diagonal entry is 2. And you add plus 1. So if you add plus 1, it becomes the 3. So let us highlight this in the red color. So 2 plus 1, this become 3. This entry become 3. Again, in the row 8, G is not equal to C. So you will look in the up, that is 3. You will look in the left, that is 2. So maximum of 2 and 3. So that is 3. So you will write 3 here. Then in the row 9, A is not equal to C. So you will look up is 3. You will look left, that is 2. So maximum of 3 and 2, you will write 3 here. For the row 10, G is not equal to C. So you will look up is 3, and left is 2. So you write the maximum, that is 3. For this last entry, the row 11, T is not equal to C. So you look up is 3, and you look left, that is 2. Maximum of 3 and 2, 3 you put here. I hope the way of filling of the entry is clear. Similarly, you will fill up the 4th column, okay, and so on. We fill up the 5th column, and then the 6th column. Can you try to fill up the 7th and 8th column on your own? So what is the process we are following? We, for any entry, says we want to fill up this entry. So we'll check whether yj is equal to xi or not. If it is not equal, we'll take the maximum of the left and the up. If it is equal, we'll take the diagonal entry, add plus 1. So this is the thing we are doing. So this is the 7 and 8 and 9th. And so finally the table, like after this, the table look like this. This is our desired answer. The LMN. This is our desired answer 6. So this is our final table. If you have any doubt, please write your doubt in the comment. I will help you to understand. I hope you have understood the process of filling the table. It is very easy. Now let us understand to backtracking so that we align the string properly. So we have started from the 6. You see that this G is not equal to this T. So this has, and the maximum is from the up. So we have come from the up direction. So we have put a up arrow here. Next, in this cell, the row 10, column 9, the 6th, this G and G is equal. So it is coming from the diagonal entry. It is coming from the diagonal entry. So we are here at the 5. Now this A and this G is not equal, but this is coming, the max is coming from the up. So we move in the up direction here in the row 8, column 8. So this row 8, column 8, both side you have a G and G. So it will come from the diagonal entry. So you have pointed a diagonal like this. So you reach to the row 7, column 7. So here also C is equal to C. So you move to the diagonal entry and you reach to the row 6, column 6. Again here T is equal to T. So you put a diagonal because it will come from the diagonal side. So you reach row 5 and you reach here row 5 and column 5. Now this is the J side, you have T and this side you have G. So this is not equal. So this is not coming from the diagonal. This is either coming from the left side or upside, and both are equal. So you can choose any of this path. I have chosen this up path here. So we come to the row 4, column 5, and this G is not equal to T, and the max is coming from the left side. So we come here. This again, the G is equal to G. So we move in the left, right. So this G is equal to G. So we move in the diagonal direction and we reach the row 3, column 3. Again, this C is equal to C. We move in the diagonal direction. We reach row 2, column 2. This is equal to 0. This T is equal to not equal to C. So we can come from either the up or the left. I have preferred the up direction. I have to just show one of the alignment, not all the alignment. So we have moved to the row 1, column 2. Again, this is not equal. Row 1, column, this is not equal. So we have, and the maximum can come from the left or the up. So we have chosen the up direction. Now this T is not equal to empty string. Okay, so this we can, here we have to reach to this 0 0 cell. So we have to move the left and left. So we have reached finally here. So this is the backtracking and how to align the string. So if xi equal to yj, align xi with the yj. Move diagonally to I minus 1, j minus 1. If xi is not equal to yj and ci minus 1j greater than ci j minus 1, means you are coming from the upside. So you align xi with a hyphen or an empty string, empty character. Okay, so in this case too, you assign xi, you align xi with a empty string. If xi is not equal to yj and ci j minus 1 greater than ci minus 1j, it means your value is coming from the left, then align hyphen with yj. So these are the rules that we have to follow and continue this process until you reach 0 0. So this is the process that will follow and we'll get this alignment. So we'll start from here. Since we have moved up, so we'll align xi with hyphen. So this is how, and we have written the action xi and yj. So in the first entry, we'll start from the last. So this we have moved up. So we'll assign xi with hyphen. Then we are moving the diagonal. So we'll put xi and yj, g and g. Then we are moving up. So again, we will put hyphen below the a. Okay. So then we are moving the diagonal. So G will be mapped with this G. Again, we are moving with diagonal. So this C will be mapped with this T. Again, we are moving with diagonal. So this T will be mapped with this T. Okay. Then we reached at this point. G is not equal to T. And we can move either in the left direction or upward direction. But we have chosen the upward direction. So we'll put a hyphen below the G. Then we are moving in the left direction. So we'll put the hyphen above T above YJ. Okay. So we reached here. Now we are moving in the diagonal direction because the row 4, column 4, the G is equal to G. So we are moving in the diagonal direction. So we'll put G is equal to G, align both Xi and Yj. Again, we are moving in the diagonal direction because C is equal to C in the row 3 and the column 3. So we'll put this C together and put diagonal entry here, diagonal action as a diagonal. Now we have reached row 2 and the column 2. We can either go in the left side or up side. So we have to form or find only one alignment. So we have chosen to move upward. So whenever we are moving upward, we have to align xi with a hyphen or empty character. Again, we have chosen to move upward. So we have aligned a with a empty character. Then we have to move the left. So we have to align the empty character with a T, and again we have to move left, so we have to align empty character with a G. So this will be the alignment of the X and Y, and you can see that there are the two string common here, two character common here, three character common here, and one character common here. So 3 plus 2 plus 4, 3 plus 2 plus 1, total it is giving 6. So your final answer is 6. Longest common subsequence is 6 between X and Y, and this will be the table. Okay, so the algorithm will look like this. You initialize ci0 equal to c0 j0 for all I 0 to m, j equal to 0 to n. M is the length of the x string, n is the length of the y string. Then for I equal to 1 to m and j equal to 1 to n, if xi equal to yj, cij will be ci minus 1, j minus 1 plus 1. So this you are taking from the diagonal entry. Otherwise, Cij will be maximum of Cij minus 1, comma Ci minus 1j, and the final answer will be Cmn. So this is a pretty straightforward algorithm using the dynamic programming for longest common subsequence. And the major time will be in this loop. There are two loops. Both are independent loop. Okay. So I goes for m1 to m time, j goes for 1 to n time. So runtime will be nm. Space, since you need a table of n into m to store, so the space complexity is nm. So can you tell me the optimized, if you want to reduce the space, how much space you need? At any time you need only 3 entries. So you can also do this in the constant space. So the key takeaway away from this lecture, what is the problem statement? Find the length and the sequence of longest common subsequence between two sequence x and y using the dynamic programming. Why DP? Because LCS has an optimal substructure and overlapping subproblem, making DP a optimal approach. So what was the DP state definition? Cij, length of LCS of the prefix x1 to I, y1 to j. And the recurrence relation Cij would be 0 for the initial case if I equal to 0 or j equal to 0, if one of the string is an empty string. Otherwise, it will compare if xi equal to yj. If xi equal to yj, it will go to the diagonal entry ci minus 1, j minus 1 plus 1. Otherwise, it will be the maximum of ci j minus 1. This is the one subproblem. Another subproblem ci minus 1j. So this is the key takeaway from the LCS lecture. So the what we have for approach followed, we have followed the table creation, proper table structure, table initialization, step by step table filling, column by column, and final length will be given by Cmn. Backtracking to obtain the LCS sequence and the alignment. Time complexity OMN, space OMN. Okay. So how to write this is in exam. So clearly define the DP state, write the recurrence relation before filling the table. So at least one table filling steps, and for remaining entry, just the table is sufficient. Mention the time and space complexity. So these are the tips to optimize your marks and the time in the exam. So LCS is a high frequency 10 marks question with a common variation, finding only length, finding length plus alignment of the sequence, and the algorithm plus time complexity. So these are the three components that they may ask in the dynamic programming. Okay, so in the next lecture, we will discuss the matrix chain multiplication. So in the dynamic programming, this 0-1 knapsack, 0-1 knapsack, the LCS and MCM, these three are high probable questions that will carry the 10 marks. And once you understand, this is very easy to score. So let us see in the next lecture, where we'll learn about the matrix chain multiplication using this question. Thank you everyone for your time. Please let me know if you have liked the lecture, if you have understood it properly. Please like, subscribe, and share this video with your friends. Also comment in the also comment the topic on which you are facing any difficulty or you want the lecture or any solved problem from previous year.